Nearly everyone is talking about Industry 4.0 and big data, but have you ever thought about what this means for your plant? More and more applications send data to specific servers via the plant network. This can be quality data for your reporting obligations, or even high-resolution video images for quality assurance of your processes. The result? Ever greater amounts of data need to be transmitted, but what impact does this have on your communication networks? They are growing more complex, and bottlenecks could occur. One thing is certain, the PROFINET communication with the I/O data is secured. But your TCP/IP communication is also important to you. SINETPLAN, the Siemens Network Planner, helps you handle this challenge. You can simulate and calculate your system already during the planning phase. This gives you transparency and enables you to always know exactly what is going on in your plant. You can thus identify problems during commissioning or even prevent them in the operating phase. Using an example, I will illustrate how quickly and easily you can perform a simulation with SINETPLAN. We'll launch a new project here. On the other hand, I have the option of importing a Step 7 project. Or in this case, we'll use a sample project that we will load now. I have prepared the project, my first SINETPLAN project. We can also see here the topology overview with all the arranged devices. On the right-hand side, we can see the various catalogs, and in the lower area, we see the complete details of the topology. This means that I can see the device overview as well as all the imported data flows from my project. In the first step, we want to simply go ahead and simulate this project. You can start the simulation with the icon at the top. As a result, in the Information tab, I see the information that all the ports and also the connections are below the set threshold values. I can now switch to the Result tab and see the individual values of the queue utilization or also the connection utilization. In the next step, we now add a so-called non-real-time communication. Up at the top, in the upper area of the plant, we have a VNC server, which communicates with the various HMIs in the plant. We now add a TCP/IP communication to this VNC server with the matching data. In terms of packet size, we assume 1,526 bytes. The burst is 9,256 bytes, and as an average value, let's assume a higher value, let's say 255,000 bytes. In the next step, I need to select the target device. I can select it via the search function, for example. I select HMI and see all HMIs in the plant highlighted in yellow. Here I select the HMI MP377-01 as data flow target. Now I have selected it, and I can create my initial data flow. If I change to the Data Flows tab and modify the sort order, I see, in this case, way up at the top, Data Flow 117, the data flow I created. A second possibility would be to use a so-called template out of the catalog for data flows. You can create this very easily by selecting the icon Create New Data Flow Template. Assign a name. As a version, let's call it 1.0. I could describe it here. As a category, let's use VNC connection. For the packet size, we can once again assume 1526 bytes. The burst in this case is larger, roughly 105,000 bytes, and the average rate is about 95,000 bytes. As the author, I could enter myself. And as the company name, let's use Siemens AG. I can then save this template. In the catalog, I find my created data template, which I can reuse again anytime in future projects. With this template, I can now take my VNC server at the top here again and move the template via drag and drop onto the server. It is then pre-populated with all the existing data at the left, with my source, my data flow. Since our previous target is still set as the data flow target, we close the catalog and look for the second HMI in the plant, the -02, and use this as the data flow target. I can now create the second data flow, which also can be seen down below in the data flows. Now I have added the so-called non-real-time data, a TCP/IP communication, to my project. And on the basis of this data, in other words, the combination of the PROFINET data and the TCP/IP data, I can carry out an analysis or simulation. Now I see here in the information column an alarm signal, indicating that the utilization is too high on one or more ports. If I switch over to the Result tab, I can also see the port displayed there. The key here is to now switch from the IRT data flows to the IRT and NRT data flows, in order for the system to display the proper values that interest me. If I now select a port, the topology display immediately jumps to the relevant device for which the port utilization is too high. Now I can try to figure out how to deal with this problem. In our case, we use this line switch as the single point of entry for the entire communication into the plant. We disconnect this connection and instead use the scalance here as our so-called line switch. In other words, I simply change the topology, and in the next step, I can easily perform a new analysis. In the Information tab, I obtain the information that all port and bandwidth utilizations are below the threshold values. I can, nevertheless, switch to the results and have the system display to me the utilization of the individual devices, sorted here in descending order. For this simulation, I could now generate a report and select the contents to be included in this report. This means that we keep the summary, the top 10, the list of devices. Let's deselect the entire list of queues. Let's select a folder. And I can have this report generated in either PDF or in XML. I now have this report here in PDF format, with an overview page, according to the selected content, followed by an overview of the top 10 in terms of the relevant queue utilization, bandwidth utilization, the list of all devices, and finally at the very end, the topology overview.